Okay, we continue. Before this, we already discussed null hypothesis can be used to determine and to compare between mu and x, and also to compare x1 and x2, and then also this one. I already mentioned before from the previous video when to use this and to compare between this and this, and also when to compare between this and this also. So now we go to test, t-test. T-test actually is the method to test whether there is a significantly difference between mu and x or x1 and x2. We use t-test. Okay. If you look here, how to use when we use t-test, comparison between experimental mean, which is our x bar, and then true mean, which is mu. And also we can use t-test the presence of systematic error. This is the step how to use it. Okay, if you look here, the formula here. The formula here is the to calculate the confidence interval. If you remember, this is for calculate for confidence interval or confidence limit. If sigma is not known, means the replicate is below 20. So we use this formula. For this formula is for if replicate above 20. But we more concerned on this part. The formula is between the replicate is below 20. Okay, this formula is for the confidence limit. So for t-test, we rearrange the formula here into this one. Okay, so we are going to use this to use t-test. This is the t, is the x mean minus mu, and then this is the formula. Okay, and then calculate t or z, because in this case we are going to calculate only t because our replicate is below 20. And then we compare t calculation. Where is the t calculation? From this formula. This is our t calculation. We consider as a t calculation. And then we compare with t table. Where to get the t table value? From the t table. And we have to found it from the t table. Okay, later I'm going to show you how to calculate to get the t value from the t table. And then we compare with t calculation. If our t calculation from using this formula higher than t table, means we need to reject the null hypothesis. We can say the mu is different between the x bar, means there is a significantly different between two data. For example, let's say HBB as a senior chemist and newcomer, we want to compare which is it there is a significantly different or not. So we compare by using this. If our t calculation higher than t table, then we reject. If we found from our calculation, let's say from my data and newcomer data, and then we compare. So if our t calculation higher than t table, then we reject the null hypothesis. So we can say from our hypothesis before, HBB equal to newcomer. This is our H null. But from our calculation, we found t calculation higher than t table. Then so we reject the null hypothesis. We can say HBB result is different with the newcomer results. This is how we use to use T table, T calculation. And then if T calculation, and also from here, if we reject the null hypothesis, the difference is due to systematic error. Means in our analysis, there is a systematic error. For example, for that newcomer, there is a systematic error. If T calculation from our calculation is lower than T table, so we accept null hypothesis. The difference is due to random error. So we have to compare. Okay, look at this example. And the sulfur content of a sample of kerosene was found to be 0.123%. A new method was used on the same sample, and the following data is obtained. This is the result from the two, and then this is the result from the previous method or the standard method. So we have sample, and then 0.123. This is from the previous method. And then we want to compare with the new method. They found the data, and then this is the data. So from here, then we can calculate. We want to compare between this new method with the standard method or in-house method. And we compare. So is it same or not? And by using t-test. So what we need to do? Null hypothesis mu is for 0.123%, and then x from the data here we have to calculate. So from here, then we calculate x is 0.116, and then the mu is 0.123. So we want to compare. From here we can say there is a difference, but we have to confirm it by using t-test. So this is the S value for this data, the standard deviation. So we put into formula to get the T calculation. We put into the formula, so our T calculation is 4.38. Then we need to compare with the T table. Okay. So here is stated here, T table is 3.18. Where is it? Where we can get this T table? So from the T table. So where is the T table? This is the F table. Or in this we don't have the T table. Okay, later we discuss how to look at the T table. Okay. Okay, if you look here, it's not stated what percent of confidence level. So in this case we use 95%. We look at the T table. The number of replicate is a 1, 2, 3, 4. So the degree of freedom is 3. So we look at 95% because it's not stated. If not stated, so we use 95%. We look at the T table. So we look at the T table here. Back. We go back to the T table. Okay. 3. At 95%, 3.18. So that is a T table. We go back to this. Okay. And then 3.18. Because our data 1, 2, 3, 4. So the degree of freedom is a 3. We look at the T table back. And then we get at 95%, 3.18. So we compare with the T calculation. From our comparison, we found T calculation is higher than T table. So means, what we can say, since T calculation is higher than T table, H null is rejected. Means new method is significantly different with the standard method or previous method. So we can say that new method is not okay. We cannot use that new method. We have to develop or to adjust that new method to get result which we found from our calculation. It's okay. Okay. This is how we use. Okay. And also there is other solution. We are not going to discuss this.